Hi class. In this screencast, we're going to have a high-level overview of the structured query language. Now, you might be wondering why at this point we're having an overview of something we've spent quite a bit of time on. Well, we've been mainly focused on the SQL select query, and we've also seen briefly some other examples such as create table and create schema. But that's just really one portion of the overall SQL language. And the emphasis on the SQL select statement was, of course, deliberate because that's where most people spend their time in terms of SQL. We spend a lot more time querying databases rather than creating tables and so forth. However, I think it's important that at some point we get at least a basic overview of the various segments of SQL, just so you have a high-level understanding of generally which commands are used to do which tasks, even if we're not really trying to commit that syntax to memory or to really take a deep dive at all into that syntax. So the SQL environment actually consists of a few different components. We haven't talked too much about this term of a catalog, but you can think of that as a set of schemas that basically describes the database. And there are SQL commands that help us do that. We're not really going to take a look at that. You are familiar with this term schema. Earlier in the course, you actually used the create schema command to create essentially a database on your own database server. And then the SQL, the rest of the SQL tends to fall into these three subsets, what we refer to as the data definition language, or DDL, the data manipulation language, or DML, and the data control language, or DCL. So data definition language consists of the SQL statements that we use to create the database itself, create the tables, create indexes, etc. It also includes commands which we have not seen yet to alter or remove, we say dropping, tables and other objects that might be in the database. The DML includes the commands that maintain and query the database. So DML includes the SQL select statement that we spent quite a bit of time on. It also includes commands to change the values within the table, or to add data to a table, or to remove data from a table. So that's what we mean by maintaining the database. And lastly, data control language includes commands that are part of SQL that are actually used to give privileges to the various users. Now, we won't spend too much time on that, but the basic idea is I want you to understand is that everything that relates to working in the database, including your access, is actually controlled by SQL. And generally speaking, in the production environment, somebody such as a database administrator will actually take care of these DCL issues, what permissions each user has. But I just want to give you a basic idea, that there are commands such as grant and revoke. They can give very specific types of privileges, and it goes down to the level of the object in the database. So in other words, you could have full control over maybe one table in a database and read only on another table. It's actually a fairly sophisticated process. Now, in terms of the big picture and how SQL is used, imagine that we have our database server, which is running a particular database management system. So the easiest example to think of would be our MySQL database is running on the Amazon Web Services. So that's a database instance. The end user uses some sort of application. In this course, we use Beekeeper, but it's been mentioned that there are many other applications. You also might be working with a custom application that has been developed within your organization for end users to do various tasks in the database. But whatever is happening in this application layer, it takes commands from the user and either if it's straight SQL, it's simply passed through to the database. This application might present a form to you so that your using pull downs and clickable buttons and so forth that'll help build the query. But in either case, it's turned into SQL, which is then passed to the database management system, and then those queries can be passed to the various databases that exist on that server. In terms of where the various subsets of SQL pop up, now we've done physical design. For example, you've done logical design where you've laid out which tables you're going to have and where the various attributes, and then you've already gone through a process of actually creating a table. That's the realm of the physical design. And that again is done with various commands that are part of the data definition language. Data manipulation language, they refer to this as implementation, because once the database actually exists in terms of the structure, you can use commands like insert and update to put data into the tables or to change the data in the tables. And of course, you can use select to pull data out of the tables. This is all under the umbrella of implementation. And then again, the DCL uses commands like grant and revoke to give users or to take away from users various access to the different objects in the database. And you'll notice that the DDL is shown to be part of, for example, the physical design, but also maintenance. This is reflecting the idea that once we create a database, as hard as we try to make that initial design as optimal as possible, there's always going to be some situations where we have to add a new table or create a new index or perhaps add a new column, or we might take away any of those things as well. So both in the terms of the physical design and maintaining the database, you're going to see DDL used. Same with the implementation. You might use this manipulation language to initially implement the database, but then later on to make changes, etc. So again, in terms of the database, the data definition language, there's essentially three main statements that are used, and you've actually seen all three of these, so I won't spend too much time on them. But the create schema creates, and this definition is a little bit different than what we've seen before. Here it's saying it defines a portion of the database owned by a particular user. I should mention these slides are developed for a more generic presentation. It's not specific to MySQL, but again, we can always think of schema as another word for schema would be database. So let me just clarify. I'm going to put a DB there for database. It's not so much oriented to a particular user. And then of course create table we've seen before, and create view. Again, these are essentially the three main things that we do with data definition language. So in terms of table creation, again, I know this is review, but it's a good place to make sure everybody, try and connect the dots between what you've done on paper and what you might do with that create statement. Of course, we need to, when we're thinking about creating tables, we need to identify the data types for all of our attributes. We've discussed this before, varchars versus numbers and so forth. Also, we need to think about which columns can and cannot be null. We haven't actually spent a lot of time on that decision process, but you have to keep in mind that you can't simply say that all the columns will be not null, because there is just some data which we want to capture, but we can't guarantee we're going to have it. And if we can't fill in, if we say something is not null and then we can't put anything in there, we can't create a record. So you have to think about the balance between what can be and what cannot be null. Of course, you're very familiar with the candidate key fields. Of course, we need to identify those. Identifying primary keys and foreign key pairs when we're talking about relating tables. Default values. We haven't talked too much about that, but the SQL DDL statements allow you to specify default values for each of your columns. And in certain situations, that can be pretty handy. We've talked a bit about constraints. Again, not null is one example. Primary key, foreign key, unique. Those are examples of constraints. And then, of course, the actual creation of the tables and maybe any associated index. So these are all the things that we think about before we get to the SQL. And when we get to the actual SQL, don't be frightened by this slide. Again, this is coming from a textbook which goes into a lot more detail about it. But this, it is good for you to have this on hand in case you get into databases a bit more seriously, at least on the creation side. But this is sort of the formal SQL specification for the create table command. And it has a lot of optional parameters that honestly most people probably won't deal with. But it is here in all its glory. But the main thing we need to focus on is that we need the keyword create and the keyword table. And then, of course, the table name is something that you specify. And then you've got your column definitions and then whatever constraints you're going to have in there. And of course, that also includes the data. We also specify the data types, the size, default values, other things like auto increment, etc. As an example, let's look at this very simple database design. Again, this is a more business-oriented example, but it's very clear, I think, for most people. You know, we have a list of customers. Customers can place multiple orders. We have a table of products, and you see this is the classical many-to-many relationship. Well, the many-to-many relationship is between orders and products, and so we break that down with an associative entity into two one-to-many relationships. And so again, we have a table of customers, of products, orders, and what the orders contain. In other words, which products were part of each order. So I just showed this as a background because on this next slide we have more reasonable looking create table statements for those four tables. Because I'm not going to go through all of this line by line, but you can see these should look fairly familiar to you. You know, again, create table, the name of the name of the table, and then you see we have a list of attributes, a list of columns, and this is formatted nicely with tabs and lots of space, which is just again for increased visibility. And we can see that they've got a customer ID, its data type, number. They're using width and precision here, so it's 11 characters wide, 0 decimal places. In MySQL, we'd probably use an integer value here. So don't be hung up too much on the specifics of the column types, but just notice what column types they're using. Afterwards, they specify that the customer ID can't be null, customer name can't be null. The rest of them can because there's no not null constraint. And then after listing all the columns, they add a constraint, the primary key. Again, slightly different syntax than MySQL, but you get the idea. And then they specify the column that's going to be the primary key. And again, we saw a lot more fluff in the standard definition for the create table, but this is a very typical, realistic example where really we just need the name of the table, a list of the column names, identifying the column data types, of course appropriate to whatever system you're on, additional constraints such as null or unique and so forth, and then specifying the primary key. And then the rest of these tables more or less follow the same pattern. I'll let you look at those at your leisure. So that's the crux of doing the create table. And again, of course, once you've designed your database, if you actually want to have one if you actually want to use the thing, of course, we have to create these tables. Now, something that we have not done yet, and that's the idea of changing a table. And we don't have to spend too much time on this again because I'm not going to ask you to actually do this. But later on outside the course, you're probably going to be confronted with the situation where despite your best design work, a change has to be made. And this doesn't actually mean that you made a mistake. You know, once people start using your database, they're going to love it so much, and they're going to say, you know what, there's more stuff that we want to put in this database. Now, if you did a really good job designing your database initially, then if somebody hands you a whole boatload of new attributes, then you might decide that it should be its own table. Or somebody might decide they need one more piece of information about, say, an NGS sample. Maybe you weren't collecting the concentration of the DNA after it was extracted, and now somebody wants to capture that. So you figure out, you did a great design. You have to figure out which entity that new attribute belongs to, and then you go in there and you add that column. And you do this using the alter table statement. Actually, the main keyword here is alter, and then of course you can be changing various objects. For example, you could be altering a table, you could be altering a column. So if you want to add a new column, you can say alter table and then add column, or you can alter table, alter column, and so the adding column adds something new, and you specify a column definition very similar to what you would do in the table creation. You have to specify the name of the column and the data type and any other attributes, like not null, for example. Or you might change an existing column using the alter column command. For example, you might want to add a default value, or you might want to change the column type. So let's say you started off with something as an integer, and then you realize you need to store floating point numbers. You can change the column type from, say, integer to float. So here's an example where we use alter table to add a new column with a default value. So again, the keyword is alter table. This customer T is the name of the table. And what are we doing to the table? Well, we're adding a column. And the customer type is the name, varchar 2, size 10. Again, this is not really MySQL syntax. This is more Oracle, but the idea is a column type with the size. And then we're putting a default value commercial. So the key take home here is that if you want to add a new column to a table, or somehow change an existing column to a table, we use the alter table command, and then then one of these actions. In this case, this is the add column action, or it could be an alter column action, and then you need to provide whatever information is needed to make that change. Now, very simply, if you want to remove a table, it's one of the easiest things to do, and it's unfortunate because it's also one of the most dangerous things to do. But to remove a table, you simply use the keyword drop, and then whatever object you're trying to get rid of. So for example, if you have this table called customer T, you say the keyword drop, and then the object type, and then the actual name of the object. You have to be very careful with this, because SQL doesn't really provide for warnings like, hey, are you sure you want to do this, etc. An application that your business uses might have that layer, but that's not built into SQL itself. So for example, if you're doing something like this in Beekeeper, and you have the appropriate permissions, you type a command like this and execute it, kiss the table goodbye. And that means all the data in the table is also removed. So on the one hand, if you're messing around with your own personal database, maybe on Amazon or so forth, of course, feel free to practice this. You're not going to get rid of any data that's very important. And once you're out in the world working in a lab or in a business, the database administrator is most likely not going to allow you to have drop permissions. But if you do have that kind of control over a database or a schema, just be aware that while this is syntactically very easy to do, again, there's no built-in warnings and there's no undo. Your database might have some sort of backup system. Actually, I'm sure it would have a backup system, but you don't want to have to go to the DBA and say, hey, I messed up. Can you please restore this table? Just be very careful is the take-home message here when you work with the drop command. Now, the next thing is the insert statement. Now the insert statement is used to add one or more rows to a table. And this ties in again to, of course, the table has to exist. And then you have had to have gone through or thought about, what you're going to call the attribute, the data type, and any other parameters that might be involved. For example, whether things can be null or not. And the reason that you care about whether things can be null or not is because if all your fields are not null, then actually it makes it easier to insert the data. If you are allowing if you're allowing some attributes to be null, it doesn't make things complicated, but you do perhaps have to put a little bit more information into the insert statement. So for example, let's say that you have a customer, again, you have this customer T table, and you want to add a new record. This is an example where you have information for every field in the table. So if that is the situation, then this is a valid syntax where you simply use the keyword insert and into, and then you specify the name of the table. You have a parentheses here, and then you have a list of values. And this list of values has to correspond, the order of these values has to correspond to the order of columns in your table. Now we say that, in a relational database, the order of the columns is irrelevant, and that's true. But once you're actually trying to put data into it, if you're using this simplified statement, this value is going to go into the first column. This value is going to go into the second column, and so forth. And we have to have something for every column in the table. Otherwise, we're going to end up with a mismatch between the number of pieces of data and the number of columns. But if everything lines up properly, then this is, again, that simplified version. One thing I want to point out over here, you see they're using this first column is a primary key, is a customer ID, and they're just literally putting in a number. We've talked a little bit about auto increment. Most likely, when you create a numeric ID field in your MySQL database, you're going to specify it as auto increment. And if your first column is a primary key and it's set to auto increment, then you can simply skip that part and start with the first piece of data after the primary key, and this format will still work. So when you have something set for auto increment, it doesn't expect the value to be passed in. Now the other slightly more complicated syntax or style is when either you want to change the order that the attributes are listed in, or you don't have data for every column. If that's the case, you still start off with insert into and the column name, but then you provide a list of the columns that you are going to put data into. So for example, here they're specifying the product ID column, product description, etc. And then you have another keyword, values, and another list of values. And here the list of values corresponds to the list of column names that you specified here. So this way is more precise. You're not making any assumptions. You specifically account for every column that you're going to put data into and specify the order, and then you have the actual values that goes into those columns. This last example is something that I have not done very often, but it is physically possible. Remember, a select statement generates a list of rows and columns. It basically looks like a table. So if it's appropriate, you can actually use the insert into statement, specify a table, and you can actually, instead of specifying by hand the rows and the column names and the values, you can simply put in a select statement if there's a table somewhere that has all the data that you need. So this is something that's possible. I have not used it a lot, but it is something that is part of the SQL standard. Now the next thing to look at, again just briefly, is the delete statement. Now the delete statement is used to remove rows from a table. you can either delete certain rows from a table, which is typically what's done, or you can actually delete all rows from a table. If you're doing a delete of certain rows, the way you accomplish that is with a where clause. So you'll notice that the actual syntax is fairly simple. We need, of course, a delete keyword, and we have from, and then we specify the name of the table. And if we want to remove only certain records that correspond to a criteria, then we use a where clause. For example, here, anything that has customer set to HI will be deleted. If you simply want to delete all rows from a table, then you just do delete from and the name of the table. Again, be very careful. It's actually a fairly common mistake where somebody only intends to delete one or a few rows and they forget the where clause and then they blow away the whole table. Now, you might be wondering, well, what's the difference between delete and drop? Remember, if you use the drop statement, it does get rid of all the records and it deletes the entire table along with it. If you use the delete statement, the table remains, but either some of the records or all of the records are actually removed. So it really depends on what it is you are trying to accomplish. Next up is the update statement. So the update statement is used to modify data that's already in the table. Again, the syntax, is fairly straightforward. Like a lot of other SQL statements, there's a lot of things you can add to it, but the basics of it is the keyword update, and then you have to specify which table you're updating, and then you use the keyword set. So update particular table, set, and then after set is one or more things that you're actually changing. So here they're specifying the column, in this case it's product standard price, and then they're setting it to the value 775. So presumably before this command ran, either it was blank, this field, or maybe it had a different value. Probably had a different value. And now they're saying update this table and set this field to 775. Now you'll notice again that it has a where clause, because with the where clause, it will only run when this criteria is specified. So some product ID, some product with ID 7, and somebody wants to change the price in the database to 775. We don't have to see what the previous price was, but whatever it was, if product ID is 7, the new price is going to be 775. Again, be very careful when running this. If you forget the where clause, then it will, in this case, update the product standard price of every product to the same value. And again, there's not really an easy way to undo this. So again, that's why update privileges are not just given out to everybody. You do need to be fairly careful that what it is you're updating is targeted or correct, and that you don't update the whole thing by mistake. Now, we talked before about views, and this is actually a little bit of a deviation away from SQL per se, but because it's done with SQL, I thought it would be a good chance to just kind of review this. And also I'm going to introduce something which is a little bit new. It's a variation on the views that we saw before. So we have talked about views, and actually this text uses the definition dynamic view. I used to just call it regular view. But as you know, a view is a virtual table, and it's created dynamically. So in other words, the user, well, actually I take it back. The view is defined using a SQL statement, and then when somebody actually selects from the view, then a virtual table is created dynamically. So once the view is created, if user A logs in today and selects all the fields from that view, they get exactly what's available from that view. And then if somebody logs in, tomorrow, the next day, maybe some of the underlying data is changed. When they select from that view, it runs dynamically and they get exactly what data is present at that particular time. As was mentioned before, these dynamic views, no data is actually stored. All we store is basically the logic behind the query that's driving the view, and the tables themselves, the base table is where the data is stored. And again, this is based on a select statement. Now, something that's new is something called the materialized view. And the materialized view, we didn't really look at earlier. It's not really supported by MySQL, but many other database systems do support it. And the idea of the materialized view is that it's created in a similar way to the dynamic view based on a SQL select statement. However, when you create it, it actually builds a physical table with the results. So it actually creates a copy of the data, and the data is actually stored. And so to be of much use, this materialized view has to be updated periodically. Usually the database management system allows you to specify how often the underlying query will run. Sometimes it's once a week, sometimes it's every day. But the idea is that the underlying query, which is presumably something that's fairly complicated, will run on a regular basis, and the materialized view will be refreshed periodically. What's the advantage of this? Well, some of these queries can take a long time to run. So perhaps you have them set to run during the middle of the night, and where that materialized view is refreshed. And then when folks who need to access the data are trying to pull data out of the database quickly during the day, instead of running a complicated query, they can access that materialized view. Because all the data has already been copied into an actual physical table, the data retrieval is much faster than if you were running a dynamic view. Remember, the dynamic view is there for convenience, but it still has to run when you ask for the results. The materialized view is essentially a cached version of it that has the data ready for presentation when it is called for. We've seen create view before. Essentially, we just take an appropriate SQL select statement and we add the create view keyword. We give it a name, and then we say as. That connects the creation to that SQL select statement. This check option is something that's designed for what they refer to as updatable views. We don't worry too much about that. We haven't really discussed that, and that's not important for this discussion. What are some of the advantages of these dynamic views? Well, we've talked about this before. If you create a view that does a complicated query, then when users need to get that data, it simplifies their querying commands. It can also assist with data security, because instead of giving people access to all the base tables, you can give them access just to the data that's been defined in the view. It does help with programming, because you allow the programmers to get an easier look at the data, which means their code can be simplified. Because we're talking about the dynamic version, so this is not the materialized. So it always has the most current base table data. It doesn't use up hardly any storage. And it does, for example, allow us to customize the view for the end user. And this idea of physical data independence, that means, that if things change behind the scenes, if you alter something in the base tables, you can update the view in such a way that the end user never sees those changes that occur in those back-end tables. It does use some processing time whenever the view is referenced. That's not really so much an advantage. They may or may not be directly updatable. We didn't talk about that before, but there are some situations where you can create a view and allow people to run update statements against the view, and the changes will actually trickle down or trickle up back to the base tables. That really depends on how complicated the view is, and generally speaking, it's probably not a good idea, but technically the SQL standard allows you to do that. And as always, you should use views with your own discretion, or with the DBA's discretion. Something I want to go through this very quickly, because I want you to be aware of it. And again, this is part of, it's not really part of SQL in terms of queries, but we use SQL to create them. And that's these ideas of routines, functions, procedures, triggers. These all fall under the umbrella of stored procedures. And I don't really have that on the slide, so I'm just going to try and write this in. Hopefully I won't make it too sloppy. Stored procedures. Okay, not the best handwriting, but hopefully you'll be able to remember that. And this idea of a routine or a function or a procedure, that's really sort of splitting hairs on definitions, but essentially in all of these cases, it is a bit of scripting or programming that is built into the database. So it's a database object, kind of like a table. But instead of just simply returning data like a query, it can do multiple steps. So it might search a table for data, then make some changes based on what is found. It's really in the realm of programming. And the reason I bring this up is, you've seen that some public databases, for example, are very large. Even just looking at a couple of, at one database on UCSC, we see that there are thousands of tables, and some of those tables have hundreds of thousands of rows. We've been very careful not to overload our system, bringing down all that data. Now, there are things like aggregate functions and other things that, those things run on the server, and that means we don't have to actually download all the data to our local computer before we can work with it. And these stored procedures are an extension of that. Imagine that you want to do serious programming against the data in the database. So one way is that you download all the data to your computer, then your program runs, and then you have a result. That could generate a lot of network traffic, and again, it might actually overwhelm the resources on your computer. By using these stored procedures, the logic of these programs lives on the database server, right next to or in very close proximity to the actual data. And so once they are developed, and again, that's beyond the scope of this class to create these things, but once the database programmers create these stored procedures, they might give the users like yourselves access to them. They may want certain parameters to be input, etc. These things have to be defined and explained. But you can run these stored procedures from a program like Beekeeper, and you're essentially executing these programs. They run on the server. They may take a few minutes or a few hours to run, but then once they're done, the results, and just the results, come down to you through your application. And this reduces network traffic, and it puts the burden of computation on the database server, which generally speaking is more robust than your local machine. And one thing I'll mention is there is something sort of special. There is a special type of storage procedure called a trigger. And these are kind of cool because once these are set up, they actually execute automatically when certain things happen. So for example, let's say that you insert data into a table, and when that occurs, you want something else to happen automatically, maybe in another table. This is a version of stored procedure where we don't even have to ask for it to run. They run automatically, which is why they're referred to as a trigger. Alrighty, so that concludes my overview of SQL and things related to SQL for this discussion. Again, we didn't look at too much syntax in detail, and that was on purpose. Again, the main goal is that you understand the realm of things that you can do with SQL, whether it's granting privileges to a user, or creating programs that run on the server, or something simpler like adding or removing records, or adding or removing columns, or changing the structure of a table. All these things are done with SQL, and I basically just ask that you be familiar, again, with these realms and sort of the basic ideas behind it. So in other words, again, I might ask a question such as, which command would you use to remove a record from a table? Or if we need to add a new column to a table, which command would you use? Something like this. Alrighty, so I hope this was interesting for you, and thanks for listening.